Today, I'd like to give you a presentation titled Large-Scale Refactoring to improve maintainability of the top page of the Demaecan application of Thank you very much for your cooperation. First, let me briefly introduce myself. My name is Tomokazu Kudo. I have been developing mobile applications and embedded systems as an Android engineer for about 5 years. I joined Line in April of last year, and currently I am developing the front-end apps for Demaecan. This is the first time for me to use React Native, so I am learning it day by day as I develop. Now, I'd like to start with the agenda. First of all, I'd like to give you a light introduction about who Demaecan is, and I will talk about the background of why we decided to refactor for the top page. Then, I'd like to talk about the problems of the top page and the approach we took to solve them. And finally, I'd like to cover the results of the refactoring. And please note that for this session, it assumes that you have some knowledge of React and React Native. Please understand this in advance. So I'd like to introduce who the Demaecan is. So many of you who are in Japan may know Demaecan is one of the largest food delivery services in Japan and used by many customers. I'd like to look at how such a service is growing by following the numbers. Currently, the number of shops the members of the Demaecan is approximately 100,000, an increase of 1.7 times compared to the previous year. Number of active users is over 8.53 million, and it's quickly growing, and it's versus 147% of the previous year. And the top page I'm talking about, as shown here, is a shop listing screen. This is an important screen with many users' utilization rate. So rate is quite high. So background factor why we decided to do refactoring for this store list screen. Let us start by going back a bit to the history of Demaecan. In March 2020, Line and Demaecan entered into a capital and business alliance. Then in May, app engineers from Line joined us to develop the driver app and other applications. In the following year, in April, they joined the development of the Demaecan app. At this time, the app development resources increased dramatically from 2 to 10 people, but internal software quality was still having issues. Many functions exist in shop list screen. For example, the shop list is retrieved and updated by various parameters such as shop filters and delivery address information on the same day or next day delivery settings. There were many other features, but due to the lack of development resources, all the logic was implemented in an unorganized manner, and we didn't have a particularly cohesive specification document. When we first joined the project, we started deciphering the code from the code that seemed to be the key points, checking the operation and interviewing the people involved to make sure that we had the correct specification. So this process of deciphering the code was very costly, and I myself sometimes created bugs because I could not fully grasp the extent of the impact of modifications. In other words, there were maintenance issues. If a user steps on a bag while trying to find a store or shop, it raises concerns about where the service is safe or not. There were also usability issues too. The shop list screen was implemented to wait for all API responses before rendering the screen. However, as the number of shops increased, it took the time for the first view to be displayed. In this situation, users who are hungry and want to find a restaurant and place an order quickly may move on to other services. So, maintainability and usability problems existed, but we managed to work on various projects to satisfy our users. For example, there was a free shipping campaign that was implemented for Tokyo and 3 prefectures. We have conducted this campaign twice so far. Each time, we had to modify the display logic of the free shipping label. And we are also working on a UI and UX improvements. For example, we have implemented universal links for iOS and uplink for Android. This is a so-called deep link implementation. This requires not only simple screen transitions, but also switching states according to parameters. We implemented various functions in this manner, but it was very difficult to incorporate them into the existing logic. Frankly speaking, I personally feel that the campaign for Demaecan was very strong and has managed to keep users connected. However, I believe that if this situation continues, it will be difficult to grow into a service that truly satisfies users. From a usability standpoint, I believe that a project that would radically improve the UI and the ordering process could be undertaken, and that it would be a good thing to do. For example, we believe that displaying delivery times in a more real-time manner will be necessary in the future. But we'll be able to respond quickly to like that. Will the Demaecan application be able to support our expanding business in the future? Perhaps some of you may find it difficult to do. Therefore, let the people involved know about these issues related to software quality, and refactoring is a necessary initiative as a foundation for future product growth, and we decided to work on improving maintainability first. Now, I'd like to talk about what issues actually had to be resolved on the shop listing screen. There were 3 main issues. The first one was the increase in the data volume due to the acquisition of all shop data and the problem of response delays. The second was unorganized data flow. Finally, there was the issue of legacy class component implementation. We'd like to discuss each of these issues in turn. The data required to display the shop list screens obtained mainly from 4 APIs. Those APIs are, from the top, API to retrieve, store a shop list information according to parameters such as shop filters, API to retrieve a list of shops customized for user recommendations, API to retrieve a list of shops where the user has placed an order, and API for displaying banner advertisement. Among them, we were having
Among them, we have problem with the main API, the store listing API, because this API is designed to retrieve all shop data. But as the service grew, the number of stores that had no problem acquiring all the store data in the initial stage of the business increased in an unexpected number, resulting in an increase in data volume and response delays. In areas where there are lots of shop data, more than 1,500 shops were being acquired at once, and the size of that data was about 2.9 megabytes. That means that the data size was unnecessarily large to acquire all at once, and response time was about 800 milliseconds. And the time until the rendering is included, it takes about 1 second to display the data. And the user wants to look for the store shops as quick as possible, but being have to wait for 1 second is not good for the user experience. So in order to start offering to meet the new project goals, to accommodate the new plans, we had to resolve this issues, retrieving all information. Next, about data flow that took place on the shop list screen. This figure shows how the data is received from the API flows to the components. Various processes were performed on the data obtained by calling the API for displaying shops and banners, and finally, the UI is updated. The stored data is rewritten to the values required for display by formatting that data, and the content is mainly processed by the domain logic. For all shop data, in addition to the data formatting process, we also had to generate other data. And this data used to display can be a special store list, such as a list of new stores and a list of stores running promotion, such as a list of shop chains like hamburger chains, pizza chains, and these are used for the header position, and that value needed to generate this data is defined as constants in the application are extracted from the full data. So that's the main flow. At the time of us participating in this project, the data acquisition, data formatting, and data extraction process were written in a single function with more than 300 lines of implementation. And the application was implemented using TypeScript. The data type passed to the UI was any. So the implementation was not type safe. And it was difficult to parse this sequence of the events in code. And it was poorly readable, and it was difficult to modify later. And that was an issue we had with the app. Now about the component implementation. React has both class components as well as function components. In the Demaecan app, the class component has been mainly implemented. There's nothing wrong with the class component implementation itself, but the implementation was depending on the unsafe lifecycle function, so it was not good for a maintenanceability aspect. Therefore, it was necessary to either migrate in a proper fashion or switch to the function component. And as the functions were added one after the other, the number of functions within the component increased. It became bloated, so it was necessary to divide the components by function group. And also, there was no test codes either. The function component allowed in 2019 became a simpler state management and lifecycle control than the class component with the creation of React hooks. Currently, writing in function component is more about mainstream, and React officials recommend the function component usage. And by using this hook to cut out logic and implement it as a custom hook, it became a more testable implementation. And class components cannot use this hook, therefore, you cannot get the benefit from the hook. That is why we decided to switch to a function component-based implementation from class component. So these were the main challenges we had with the shop list screen. Next, I would like to share with you how we approach to solve each of those challenges. Regarding the retrieving all store list at once, we address the problem by migrating to an API that supports paging. And I will talk about the new issue that arose from the changing to the paging in more details later on. The unorganized data flow of the apps has been simplified by organizing the API and simplifying the data flow on the client side through BFF. And for the last item, legacy component implementation, we migrated to function component and changed the structure to the one that can use hook. Then let me discuss about each approach now. For the problem with shoplifting API getting all these items at once, actually before we started on this refactoring project, we had renewed the search screen. And at that time, we created an API that supports paging. And this API was created with the assumption that it will be used on the shop list screen. So we decided to solve this problem by migrating to this API. However, a new problem occurred here. It's an extraction process using all store data that was implemented in the client. Since that process was dependent on all data, fetching and paging would cause a problem with the extraction process. Therefore, the extraction process we made it perform on the backend side, and a new API is created to retrieve that respective data. So that is how we organize the backend API. The next is our approach for the improving data flow. With the backend, of course, that I just mentioned, the data extraction process that was dependent on the client side has been converted to an API. So we could remove the data extraction process from the code since it will be a flow that calls the API. And another initiative of the Demaecan app and front-end team was the use of BFF to standardize logic. BFF stands for backends for front ends, creating an intermediate layer between the client and the backend. And in addition, since Demaecan had a problem with API for some number of years of operation, so it's possible to confine the effects of these problems to the BFF as much as possible. BFF is implemented using GraphQL and Apollo and is operated under the leadership of a front-end team. And development language itself is the same, TypeScript, so the app members can contribute to the development, and they are. In its way, the data format required for the front end is done by the BFF that allow the front end to focus on retrieving data. With such efforts, the actual data flow on the client side now looks like this. And one data formatting process is no longer needed, so this logic can now be removed from the client code. So compared to the previous data flow, it's less complex and much simpler as it only retrieves data. GraphQL defines a query and requests the necessary data from BFF to retrieve that data. And this query can be generated automatically by using the GraphQL code generator to generate a hook for the query. This is automatic. And this reduces the cost of implementation of the hook itself, and at the same time prevents human errors. But since the application component implementation is still a class component, so the hook cannot use natively as is. For this reason, it's necessary to modify it into a function component.
As for implementation of the legacy class component, the main content is to replace it with a function component. So there will be a change to the modern configuration. In particular, the functions related to the header had become bloated with the 8 functions implemented. So the bloat was eliminated by dividing the unit by function. And also that the timing of this division, a snapshot test is used to guarantee the display. Now, for the state management and lifecycle chain, the unsafe lifecycle functions dependency, we were able to depart from it. Furthermore, in the query hooks mentioned above can be used for data acquisition. Other detailed logic can be separated as a functions with the utilities as a custom hook, and utility the function can be separated as needed. Unit tests of the functions are implemented. By dividing the components in this way and using the hook to isolate the logic, the dependency of each component were reduced and a more testable implementation was achieved. In other words, we are now able to improve quality by writing a test code where there used to be no test. So actually, this is the data flow. After the component reconfiguration, the components making up a shop list page retrieve data via their respective query hooks using a custom hook, correctly managing the data retrieval. In this way, the logic is carved out of the hooks, and the individual responsibilities are more clearly defined now that the components have been properly partitioned. And also, another advantage for the GraphQL is that multiple data can be retrieved in a single query. For example, in this case, a special list of the data other than the list of shops is retrieved as a single query. This allows the BFF to make a single request for each of the 4 lists of the data that would otherwise have to be queried by the API 4 times. So by changing the query definition, flexibly you can acquire the data. That is very convenient. Thus, the actual data flow of the query looks like this. The structure is even simpler now that the requests have been combined into one request. So let me talk about the results of the refactoring at the end. First, refactoring changed the configuration of the backend and the application, making it more suitable for the service. And the refactoring also resulted in improved performance and a variety of other benefits, which will be discussed in details in this section. First, I'd like to look back at how the backend was modified. It used to consist of 4 APIs like this. After refactoring, the API was properly split, and the shop list API is modified into paging-enabled API. The BFF now performs the data formatting process, allowing the front to focus on retrieving the data. Next, I'd like to look back at the refactoring of the application. In the previous state, data extraction and formatting processes were in place, and components were not properly divided. And each was implemented is a class component. After refactoring, the component is now function component divided by function, and hooks can be used. After this refactoring in this manner, the roles of each component has been clarified. Readability and ease of implementation has been much improved. Next, I'd like to talk about the performance. the data volume increase problem that occurred when all shop data was acquired due to the initial design was resolved by migrating to a paging-enabled API. This data measurement was performed in area where approximately 1,500 shops' data was being acquired. Since the paging enabled a maximum of 100 items per page, the amount of the data required for initial display was reduced from 2.99 megabyte to 327 kilobyte. And similarly, there was improvement in response time from 800 milliseconds to approximately 320 milliseconds. There was a reduction. For the user experience, there was improvement that approximately there was a reduction from 1 second to 0.5 seconds before the first view was displayed. Next, I'd like to talk about the improvement of the test coverage. And we utilize the static tool, and the test code increased by refactoring. So line coverage was 74%. And the condition coverage was 58%, and overall test coverage was about 70%. In the past, the test team consisted of 2 developers, which was a major factor in terms of lack of resources. There was not so much time to write tests. However, now we have more resources. We have more time to organize the code and write a test code, which has led to this kind of improvement. The ability to ensure minimum level of quality with the test codes leads to prevention of defects, which in turn leads to the creation of the services satisfying users. I feel that this is necessary to create a service satisfying users. Next, I'd like to talk about organize the UI specifications. What is this one? For example, the footer of the shop list has a read-in line requesting a store or shop like this. There was a condition that display that will be performed only for shops other than restaurants. But through consultation, we were able to modify the direction to always display it. This eliminated the complexity of the code and made the specification lean and simple. In the process of organizing components, we consulted with the planning team about specifications that we had questions about, which helped us organize the specifications. So this was a benefit that we started with the refactoring. So Demae-can it's a culture, and we have a good team because developers can flexibly and easily consult with each other about the improvement specifications. And I'd like to talk about the improved motivation about the development. Before refactoring, I was having a hard time modifying the shop list screen due to its complexity. And I had personally created some defects. So I was honestly in this state as illustrated like this after starting the project. But after the refactoring, implementation was organized, and I felt it was important to be able to work on the project with a peace of mind and a very positive mental attitude, which is also important. These are the results of the refactoring. So at Demaecan, other than shop list screen, in other screens, we are working every day to reinforce the functions. I hope that my presentation will be helpful and beneficial for your business operation. That's it from me. Thank you very much for your attention.
Kudo-san.
Thank you, Mr. Kudo. Now, we would like to start the Plus Talk. We have an interviewer who will be asking questions to Mr. Kudo or Demaecan to dig in deeper into the contents of the presentation. We are also taking a question from the participants too. So for those of you with questions, please use a question button at the bottom of your screen. Please send us your questions. This session's interviewer is Mr. Suzuki Wataru from Yahoo Japan. Mr. Suzuki, would you please briefly introduce yourself? Yes. Hello, nice to meet you. I am an Android application working group lead. I'm a mobile app engineer, CTO office of Yahoo Japan. My name is Suzuki. Great. So, Mr. Suzuki, any questions to Mr. Kudo? Yes. Thank you. The refactoring that you went through was very dramatic, and thank you very much for the presentation. I could see that when doing refactoring, probably the concerns for the engineers is during the refactoring, if in case we had to concurrently develop a new feature, I wonder whether during your refactoring effort during that period, did you develop any new function at the same time? Well, the shop list screen is the one that we focused on refactoring. But for other screens, of course, was handled by other teams. Multiple projects were always ongoing. So except that for that landing page, for that shop store list page, we did not have any concurrent development. I see. So you could focus your work on refactoring. I see. That's great.
And also, when it comes to refactoring, it requires a very long time and effort, and also internally, you need to address other issues, including change. But the change-related behaviors during the refactoring. So how have you verified the behavior? Well, so this is a very important part. Originally, we didn't have any test codes. So we were very careful about the performance or implementation tests. Critical logic, we tested it and implemented it so that making sure that this logic would be surely implemented. And for overall behaviors check, we ask QA team by sharing the possible impacted areas so that we will be able to release it without any issues and problems. So we make an explanation. So I say you asked the QA team. So was it before release? Yes, before the release. Of course, once we decided to perform refactoring, including a man-hour required for QA, we developed the timeline schedule so that QA will be able to finish all the tests without any issues. Then, making sure of it, we are able to release it. I see. Thank you.
So, Mr. Kudo, until yourself got involved in this project, you said you never used a React Native. Yes, that's true. We're getting a question saying that I thought that you'd be using Flutter, but I wonder whether you have ever thought of migrating to another cross-platform. So, as long as you can share, what kind of thought process was behind this refactoring? Well, this project started out with just 2 people. And their technology selection back then was, in order to do iOS and Android native development with limited resources was very difficult. So, and that engineer at that time their expertise was web engineering, so no experience with natives. So that is a reason why they chose the technology of React Native. So that was a background reason. Then we got involved. We became a team. We joined this app development team. Then, of course, after consulting with our senior management to go through this redevelopment, are we going to do that for two different platform? Then that would have diverted our limited resources. So still today, we are able to do cross-platform development using React Native. I believe that using React Natives is leading to our agilities in development. So we plan to continue using React Native.
React Native.
So React Native you have used. I personally touched upon, tinkered with it, React Native. That was the initial stage. I found that Android was unstable, even though iOS is fine. Yes. The choice, because there are too many alternatives. So, and also you needed to consider the timing too, and also of course, such consideration will be important. As a result, you decided to migrate to BFF. You utilized the same TypeScript. That was also a beneficial decision, right? Yes. So the usage of the TypeScript, originally, including JavaScript, we had not had many experiences, the usage of the TypeScript, that we decided to do BFF development. Apps team, the knowledge about TypeScript improved. So BFF was not just entrusted to the front team only. We had distributed resources and were able to develop very efficiently. In hindsight, that decision was very good and worked well for us. Thank you. And amongst the performance, you said that there was a visible improvement of the performance too. You showed it in the slide. So shop review or any reactions or positive feedback from the end users about this. As long as much as you can share the information, we hope to have such information too. Well, excuse me, the feedback from the users. Well, we have not caught up well with that feedback, their feedback yet. Frankly speaking, I see. Thank you. So, as I have listened to your presentation, when I using Demaecan services, I always be reminded of your experiences. Yes.
実際
So this project made this app more user-friendly, very easier to use, and it's for the developer too, for the engineer too. I'm sure you're feeling this productivity improvement through this efforts. I wonder until you receive the ticket and to become a full deployed to provide answers as a full deployment. I wonder whether there's any changes in that process. Sure, we are not really taking these exact values, but whenever we needed to do any feature enhancement, let's say we spend 1 week of work. Maybe now I feel like this is just my feeling, but we can do this in half the time. I see. But that's enormous productivity improvement. Yes, but this was a major refactoring project, so I would very much like to experience such an improvement in our environment through refactoring. That's great. And after refactoring, you've already introduced us that it was not testable at all and became testable. And now you're able to deploy things that are necessary in that methods, I wonder what kind of what are the new ways that you are now able to accommodate through after the refactoring? In the beginning, we were using class component. It's really a legacy deployment. So there were many restrictions and limitations that came with using class components. But now, with the function components, many things it's easier to deploy. And we're able to utilize third-party library through hooks. That really helped us with development to make our development efforts more efficient. I think that's really the biggest reward for us, the engineers.
ありがとうございます。
Thank you very much. Indeed. Yes, there were areas it's difficult to test for applications. There might be some apps, the ones equipped with the camera, to perform auto testing. So sometimes we will be wondering why these applications are not suitable for automated testing. But you resolve the issue on your own, and this project is a very large-scale project. So this will be a very good for reference. And we had many apps with a long history. So definitely we'd like to refer to your case to conduct the refactoring as a needed basis. Yes, I strongly felt it that way. Thank you very much. Thank you. And also there were some questions if React Native was adapted, and you covered it in your presentation, but other vendors like Mercari US, there were some businesses having migrated to React Native. So for React Native is not so popular and not well adopted in Japan. Why the reason for that situation? This is my personal comment, but there might be some difficulties for the usage of React Native. Have you had any difficulties? Well, learning cost is a bit high, so that's personally I found it a challenge. But ultimately, this issue will be resolved. And elsewhere, web engineers will find it easy to be a part of the process. That's a benefit of React Native. I do not know the reason why the adoption of the React Native is still at a low level. That's my personal comment. Thank you. So the cross-platform, there are many cross-platform availability, and sometimes it's faded away along the way, so it's difficult. But my personal impression about React Native is that when the version of the React Native is updated, third parties, including the import operations, completely changed. So that is a hard part. But for other platforms, we cannot guarantee that no such phenomenon will be taking place in other platforms too.